Hello and welcome to my home tuition's YouTube channel. In this video, we are going to explore the concept of the inverse normal distributions. This topic builds upon the normal distributions concept you have learned earlier, and we will break it down into easy to understand terms with engaging examples. We will also discuss using the Casio fx-570EX class width calculator to find the answer. This video is sponsored by Casio Malaysia. The inverse normal distributions, also known as the inverse Gaussian distributions, is a method used to find the data points corresponding to a given probability within a normal distribution. In other words, if you know the probabilities of a particular outcome, the inverse normal distribution helps to find the data point associated with that probability. Before diving into the inverse normal distributions, let's quickly review the normal distributions and Z-score. The normal distribution is a bell-shaped curve that represents how data points are spread around the mean. To calculate probabilities, we use Z-scores, which tell us how many standard deviations a data point is from the mean. The formula for a Z-score is Z equal to X minus mu over sigma, where Z is the Z-score, X is the data point, mu is the mean, and sigma is the standard deviation. With the inverse normal distributions, we work in the opposite directions. We start with a probabilities and then we find the corresponding data point or Z-score. To do this, we use a standard normal distributions table, also known as a Z-table, or an inverse normal distributions calculator. In this video, we will use the Casio fx-570EX calculator to find the Z-score from a given probability. Now let's learn using the Casio fx-570EX class width calculator to find the Z-score of a normal distributions from a given probabilities. So in the calculators, we go to menu, and distribution is in the 7 mode, so we go to 7. And then we want to find the inverse normal distribution, so we go to number 3. So here they show us the screens. They would like us to key in the area, the sigma is the standard deviation, and the mean, mu. For the standard normal distributions, the sigma equal to 1 and the mu equal to 0. So the only thing that we need to key in here is the area. The area is equal to the probability. In previous video, we learned that the probabilities of normal distributions is equal to the area of the graph. For example, in this case, if the sketched area occupies 20% of the area below the graph, the probabilities will be 0.2. Therefore, in the calculator, under the area, we key in 0.2 and then press equal. For the standard deviation and mean, for a standard normal distributions, we leave it as the 1 and 0. Therefore, we press the equal sign one more time. Now we can see that the Z-score equal to negative 0.841620847. And from the graph, the horizontal axis is the Z-score, and we know that this point is equal to negative 0.8416. Take note that the calculator will calculate the Z-score for the area from the negative infinity to the boundaries of the area enclosed. If the area is at the right-hand side of the curve, the Z-score will still be the same but become positive. This is because the curve of the normal distributions is symmetry. Okay, now let's see these questions. This is a past exam question 2015, paper 2, question 10b1. Diagram 10 shows the standard normal distribution graph. So this is a standard normal distribution graph. And this graph representing the volume of chili sauce in bottles produced by a factory. It is given the mean is 950 centimeter cube. So the mean is equal to 950 centimeter cube. And the variance is 256 centimeter to the power of 6. So variance is sigma square. Sigma is standard deviation. Sigma square is variance. So this is equal to 256. The percentage of the volume more than V is 30.5%, which means the probabilities that we get the volume more than V is equal to 30.5%, which is equal to 0.305. So this actually tells us the probabilities that we get volume more than V. Okay, so this is a standard normal distribution graph. So let's convert this to the Z-score. And to convert this to Z-score, X minus mean over standard deviation more than, same thing, V minus mean over standard deviation, and this is equal to 0.305. Okay, so X minus mean over standard deviation, this is the Z-score, and this is V. The mean is 950, so let's write this 950, and the standard deviations is the square root of the variance, so square roots of 256, and this is equal to 0.305. Now let's use the calculator to find the Z-score. So the area is 30.5, and therefore the probabilities is 0.305. So in the calculators under area, we key in 0.305, 0.305, so equal, and we leave the standard deviations and mean as 1 and 0. So the answer is negative 0.5100 something. And just now we learned that if the area is at the right hand side, we need to convert the negative into positive. So therefore the Z-score is positive 0.51. The Z-score is greater than 0.51, equal to 0.305. And when we compare these two, then we can tell that this V minus 950 over square root 256 is equal to 0.51. So V minus 950 over the square root of 256 equal to 0.51. Therefore, V minus 950 equal to 0.51 times the square root of 256, and V equal to 0.51 times square root of 256 plus 950. So in the calculators, let's go back to the calculation mode. So 0.51 multiplies to square root of 256 and then plus 950. So the answer is 958.16. So V equals to 958.16 in centimeter cube. So this is the values of the V. Now let's see another past exam question. This is the questions for the papers 2017, paper 1, question 25. Diagram 10 shows a standard normal distribution graph. The probability represented by the area of the shaded region is 0.2881. Find the values of H. In order to use the calculators to find the H or the Z-score, we need to know the area from the negative to this boundary, because it will only give the Z-score from the negative infinity to this boundary. Since the area of the shaded region is 0.2881, and then the whole area at the left hand side is equal to 0.5. So therefore, for our Px less than H is equal to this area, which is equal to 0.5 minus 0.2881. This is equal to 0.2119. So this area is equal to 0.2119. So now let's go to the calculators mode 7. Okay, inverse normal distribution. So the area, we key in 0.2119, 0.2119. Okay, equal. Okay, so they give us the answer negative 0.7998. So px less or equal to negative 0.79998 is equal to 0.2119. When we compare these two, then we know that h is equal to negative 0.7998. So this is answer for A. Now let's see B. X is a continuous random variable which is normally distributed with a mean mu and the variance of 16. Find the values of mu if the z-score of x equal to 58.8 is h. We know that the z-score is equal to x minus mu over the standard deviation. And from here, we know that this is equal to negative 0.7998. So the z-score is negative 0.998. And it is given that x is equal to 58.8. So 58.8 minus mean. Mean is what we want to find. And then over the standard deviations. The standard deviation is the square root of the variance. So 16. Equal to negative 0.7998. Okay, so 58.8 minus mean is equal to negative 0.7998 times square root of 16 equal to 4, so times 4. So therefore mean is equal to 58.8 plus 0.7998 times 4. So this is equal to 62.00. So this is the mean of these distributions. You have just learned the basics of inverse normal distributions and how to find data points corresponding to specific probabilities. This concept is a valuable tool in understanding real-life situations where you need to identify data points based on probabilities. Keep practicing and you will become an expert in no time. Thanks for watching, and you don't forget to like, share, and subscribe for our engaging tutorials.